Welcome all to today's Passive House Alberta Coffee Talk. My name is Frank Crawford. I am the Education Committee Lead for Passive House Alberta, and today we are talking with Ryan Hall, who is the Housing Manager for the Siksika Nation, and Mauricio Soto Rubino, who is the Associate Professor of Architecture at the School of Architecture, Planning and Landscaping at the University of Calgary. And they will be talking about the Star Lodges, which is the largest 3D printed building in Canada currently, and is currently in construction on Siksika Nation. Unfortunately, Ian Arthur, who is president of Nidus 3D, who is the company printing the building, is not able to join us today. He had something critical come up, but I won't take any more time. So take it away. I believe, Ryan, you're starting, and then Rizzo might be around as well for some questions.
Exactly. Yeah. Thank you. Nice to meet everybody. And so I'm the housing manager with Siksika Nation, and I've been in this role for about 18 months now. And so this presentation is going to go over just a little bit about the why on this project and how it came to be and the process of going through the design process, and then we'll get into some construction and sort of where we're at today. So the project we call Kakatusoyists, which in Blackfoot translates to the word Star Lodges. And so this is a picture of a rendering that Mauricio and his students had put together of one of the buildings. And so these are fourplexes. We'll get into all the details in a moment, but I'll just take you through, if you're not familiar with Siksika Nation. We have under the Siksika Nation Tribal Administration, Siksika Housing, which I'm in charge of, is essentially a nonprofit housing company that works within the nation. And we have a motto, and it's very simple. It's "We shall try hard to serve you well and to provide you with a good home." Siksika Nation itself is about 100 kilometers from the center of Calgary towards it's actually the second largest reserve in Canada. On-reserve population is about 4,000, and off-reserve is about 4,000 again, for a total population of 8,000. And the communities are quite distinct. You're not going to find these communities named on any kind of map, but they have unique characters. It's a clan-based system, largely, that's carried over through generations. So we find a lot of families live in the same areas, and these areas are named uniquely for various reasons in history. Communities like Susie Slough, Chicago, Washington, all adopted names through various oral histories. And so the need of housing is very severe for the nation, and like a lot of First Nations, we have a massive housing gap. So when I started, first thing I did was commissioned a short-term housing strategy, and so this informed us what our housing gap was based on our population projections, which we have a very rapidly growing housing population. We're going to need 973 new homes over the next 20 years to close our housing gap. And a lot of our existing housing is aging and failing, and we have a lot of pressure for off-reserve nation members wanting to come home. We also have a limited funding environment to tackle this problem. And so we're looking at any and all options to pull in funding to try and build more housing to meet our needs. So our population projection is expected to surpass 10,000 people in roughly about 2038. And families tend to be quite large and multi-generational. But we need housing types across the entire housing continuum. And so this project came to be because we have a high acute need for emergency housing right now, especially for singles incomes. So this is just a little video we put out at the start of the project. And just to kind of kick it off, this is right after we got our funding approval. And at this point, the machine had been delivered. This is the 3D printer just sort of lying on the ground. The project was named by an elder and knowledge keeper Eldon Wieselchild, and was gifted the name Kakatusoyas. So these are all 1-bedroom, 1-bath units with complete laundry inside. And so these homes are really, the name is significant because it's to provide direction and good intentions for the future occupants of these homes. Because as you can imagine, there's a lot of intergenerational trauma and things that play in the community, and people need a space for healing. My constant model for my team is housing is central to community health. And so without adequate housing, our communities really do suffer. And we're trying to tackle this community health issue by providing good, sustainable housing that's going to last for generations. And we talk about generations in terms of, in Blackfoot teachings, planning for 7 generations is a huge thing. And so well, I'll get into a little bit about 3D printing. So these houses were designed through community input by Mauricio and knowledge keepers and elders on the nation. And then from there through the software, it gets translated from AutoCAD through Slicer software and into a language that the 3D printer understands. And that language is identical to the type of language that you'll have on a desktop plastic 3D printer. It's called G-code. And so these computer guided building process, the benefits are, and as we have seen, that it's a very rapid form of construction. The walls of these buildings can be printed for a full fourplex, can be done in about 36 hours. And there's a lot of ability to have unique and flexible design of the technology, because you can start to do things like curved walls. Is a lot less waste because you only use the raw materials you need to actually build the homes. We're expecting an insulation. I'll show some pictures of insulation in a little bit, but we're expecting the walls to be about an R32 insulation. And the MPA value for this concrete is quite high. I don't remember the exact number, but it's better than bridge quality concrete and edging towards something you might see for bomb shelters. So these are going to be around for a very long time. And then our collaborative design process started about a year ago now, exactly a year ago, with these are the students from the university, from Mauricio's class, going through an exercise of getting ready to design different types of housing for the nation. So they're Masters of Architecture students, and focused from January to April last year on creating housing design ideas for the nation. Later on, we engaged as Bren Littlelight, who is one of the nation members who gave us input into the design of the Kakatusoyas project. So here's the students learning from her, and a picture of our team together here at Blackfoot Crossing, where we did a public presentation on different types of housing designs for the nation. One team put together a concept for 3D printed housing. And so we received, after that, we'd put a proposal forward. We became aware of some funding and put in a proposal, and ultimately received the funding, which was $2.6 million to build these 4 fourplexes using the 3D concrete printing technology. And this is Indigenous Services Canada funding. And so here's a picture of our design team, a lot of members of Siksika Nation Tribal Administration and Nidus 3D and Mauricio, and construction companies talking about how we were going to actually move forward with the project in the planning and design phase. And then we ultimately selected a site here just on the east side of the 547, south of the 901 highway. To the north there is a community that's been under construction. It's nearly finished. It's Children's Village for transitional housing for families. And then in this half circle here is the site location for the 3D housing site. And so we'd elected to frame this circular space with the four fourplexes here. So 16 units in total, and ultimately internal driveway there that'll take vehicle circulation in and out of the site. The actual floor plan here are all identically designed units with a kitchen off the living space. If you're looking at the unit on the bottom left corner, so on the left side of that unit, you'll find the kitchen, and then the dining area, and then living area all sort of combined. And then on the right side of that unit, you've got your bathroom and bedroom. And so one of the design decisions was the internal wall that goes across the long horizontal section along the center line there houses all of the servicing, so electrical and plumbing, gas, all goes through that central wall and connects to those kitchens and bathrooms. And then in terms of the design, it's really influenced by the Blackfoot Lodge. The term lodge is really synonymous with the word teepee. In Blackfoot culture, tendency to use the word lodge to describe the teepee-like structures, and so that was one way of for us to think about the design of these homes and ultimately try and reflect that part of Blackfoot culture. So this is a slab on grade project. We've got frost walls and footings around the entire perimeter to support the concrete walls. A design decision was made early on. We'd initially thought we'd do the internal walls using 3D printed concrete, but of course, in doing that requires that you provide those footing and frost wall supports underneath on the foundation. And at that point, we were using so much concrete. It was pushing the costs up quite high, but it was also probably in hindsight a very good decision to go with conventional construction, because the printer would have had a hard time dealing with all of the servicing coming through the slab. I'll show some pictures of that, but if the print head hits anything, there's automatic sensors which sort of shut the whole system down. So you've got to design it in a way that you're printing all free and clear from any encumbrances that might be projecting out of that slab. And I do know in Ontario, Nidus has done a project where they've actually 3D printed a foundation as well. So for us, we went with a conventional construction for the frost walls, footings, and slab. And then so the printer took over the remainder of the construction up to the roof. And then so we have a wooden truss roof system that went on top. And so here's just a rendering of those units. So we've got each unit has two large windows, one in the bedroom and one into the kitchen and dining area. And to provide some privacy, concrete planters and plantings going in front of those windows. So this was the day of breaking ground on the first unit, which was in August of last year. And so basically going down, and then this is putting in our believe our footings to start off with. And then ultimately, frost walls, we can see this is attached to community servicing. One thing the nation is really trying to focus on is connecting to existing community sewer and water systems. We have done a lot of rural development using septic and well, which is quite a bit more expensive for us. And so our future development opportunities are really going to be focused on taking advantage of the community systems we have, because it significantly reduces our ongoing operation and maintenance in future. Wells and septic systems can be very expensive to maintain, and do frequently have issues, especially with water. We have water bans in a number of areas due to things like uranium being in the water, or manganese, or different types of things. And so these community systems are very important to us. So you can see that this is being connected to those community systems. And so this is the gantry being installed for the 3D printer. big concrete blocks to support all of the pillars. That was another design decision to minimize the amount of concrete we were pouring. The original concept was to pour footings for these concrete or for this printing machine in the ground and then move from site to site. But we knew that if we were able to build these concrete blocks and counterweights, that it would be something we could move from site to site. And so this allowed us the ability to set up and take down and move the entire operation from site to site. So one of the cost considerations in 3D printing is the mobilization and setup and takedown of these printers. It's quite labor intensive. You need a crane to mount and dismount all of these components. And so this is why this technology makes a huge amount of sense for building multifamily, because you can spread that cost over a number of more units. Whereas you do, if you do this for a single detached housing, your costs on mobilization are going to be higher because you're only building one unit at a time. Other issue, of course, starting to build in August wasn't ideal, but our funding locked us into a winter construction timeline. So for better or worse, we had to go through with it. And so that forced us to look at innovative ways of actually heating and hoarding a construction site like this. So this is a tent we rented from Event Tent Rentals in Calgary. It's a type of tent you might use for a music concert or something during the Stampede, but is serving a purpose for this construction project. But there, it adds a little cost to your overall construction and your bottom line. So this is the tent set up, and we're just about to start the first print. You can see here the servicing coming out of that long center line in the floor, and rebar being prepared to be installed along the walls during its installation. And so if you can imagine, building a internal concrete wall around all this infrastructure would have been quite challenging. And so therefore, that transition to conventional construction is a better decision for us than trying to have the printer run into all of this equipment. The printer runs off of a batch plant. So this is the batch plant here with a concrete pump. All the raw materials are on site, including the water connection, and then fed into this machine and then mixed into batches. It's a proprietary mixture of cement, and it's something that we have sourced from Lafarge. I personally don't know all of the ingredients in it. It's something that's, because it's proprietary, it's a recipe that Nidus owns and is used in the Cobod printers. And so Cobod, you see printed all over here, is the manufacturer and designer of these machines. And so this is just inside the batch plant as we're starting to mix the concrete. And then this was the first print. And so what you're seeing here is the first sort of wavy internal wall. This goes in between the inside and outside concrete veneers and forms part of the insulation barrier. And so here's a little video of it up and running. So yeah, you can see we've had you can see the color differences between the bottom and top layer here. So the bottom of that, the lighter colored layer, was printed the previous day, and so this is the second day of the print, and just printing that outside veneer there, and the electrical conduits you can see coming up out of the slab and through that internal wall. And then ultimately, we mount the receptacles and the conduits for this within the concrete itself as it's getting printed. And so here's probably day 4 of a print, and you can see we're starting to get the outlines for the windows, and then the you'll notice there's a metal plate there to support the concrete around the window, and then we'll have metal plates that get installed on the top side of these windows as well. And so here's after the first building was printed up to where the roof is going to meet the bond beams. And so all of this is now just sort of curing. Another design decision we made, which didn't include the first building, is heading into winter, we needed to think about keeping these slabs warm to prevent frost heaving. And so on the second, third, and fourth buildings, a glycol heating system was installed under the slab, and was run through generators to keep those printed as we progress through the construction process. So here's a picture of one of the walls after it's been insulated. This is a spray foam, expansion foam insulation, which goes on the outer side of the walls. And then on the other side is just an air gap. And so all this sort of averages out. Some people comment on this and say, oh, that thin area isn't going to be very well insulated. Well, on the other side of that, you have an air gap barrier as well. So this all sort of averages out to about an R32 value. And just down in that air gap on the photo, you can see part of the electrical conduit there that's sitting in the concrete. And then on the top, this is taken with a drone, just flying over that top area. So this is us getting ready to for that bond beam, and you can see all the insulation goes right up to the top of those walls. And then here's another photo of that insulation as well being installed up to the top of those walls, which are around 12 or 13 feet high, I think. So we went with a higher ceiling because these are small units. They're about just under 600 square feet each. So to make them a little more spacious, we do have a lot of height there. And then in terms of the buildings, the roof, so it's basically brought in and constructed on site and then mounted in two parts. So this isn't all lifted on in one large roof piece. It's actually two halves that and you can see the bond beams have been installed on the top of that structure. So we're just getting ready to crane that roof structure onto the top of the walls now. On the interior, this is well into the interior framing installation and electrical. At this point, we do have power connected, and so we went with commercial grade construction on the interior. Gonna have sound separation, sound insulation in between all the units installed on these. This is just a picture looking towards what will be the bathroom on the right-hand side through that doorway, and on the left-hand side, a little utility room there, which will house the electrical panel, and then heating and hot water system. So we had looked at doing a heat pump solution for these, but ultimately decided to go with just a gas furnaces. Not because the technology isn't going to work, but because, as you can imagine, out here we do have local contractors that service our homes, and so it's very important for us, and in a First Nations context, to have equipment that we understand how to service and that we have the ability to service. And so bringing in a heat pump system would have been a very complicated venture for us, because our plumbing and heating contractors are not used to the technology yet, and aren't set up in don't have a supply chain that is easily ready to service that type of equipment. And so we're just going conventional on this for those reasons. Here we have windows getting installed. You can see on this picture, we've got some propane tanks outside. So we, as part of our heating and hoarding, to continue heating the internal spaces on here. But of course, in the winter construction, trying to get to a point where we're basically transitioning towards electrical heaters to keep the inside warm has been a very important step for us because those heating costs are significant. If somebody asked me, if I would do this again in winter, even though we've gotten through all the technical barriers and have made it happen, I would say that the cost savings on these that you gain from the rapid construction and the efficiencies of using a 3D printer were probably entirely wiped out through the onboarding of those additional heating and hoarding costs. And so for that reason, in future, we're going to be essentially demanding for our funding to be done in a way that makes sense for the normal construction season. And so we've been lobbying our government partners to make those kinds of adjustments so we don't have to incur those costs in the future. Overall, this is the 4 building sites at their various stages. And so you can see way on the left there, building 1, walls were finished and we're installing the printer on building 2. Building 3, found the slab was finished, and so it's just covered and being heated there as we wait for the printer to make it over that way. And then the 4th building looks like the frost walls have just been installed, and so getting ready to backfill that site. That large orange and yellow blob in the sort of center of the photo there is the batch plant. Interestingly, we've actually transitioned away from using that batch plant altogether for buildings 3 and 4 because the equipment itself is quite finicky. There's a lot of computerization in there, a lot of sensors, and just to give you an idea, we had a water sensor freeze and blow up on that, and it's a part that is made in France. It has about a 6 to 8 week lead time. Costs about $1,500, and so we can't control all of these things, and so we have now given that recipe for the concrete mixture to Lafarge, and they're delivering it straight in a concrete mixing truck and pumping that straight into the pump, and that's been working phenomenally well for us. So I believe Nidus is probably you might find that concrete batch plant on eBay or Kijiji sometime soon. We'll see how that goes. But yeah, it's not necessary. And so we've been able to get around that issue. And so here's, the roof starting to get installed on, looks like the 1st building. One thing I wanted to mention is how these kinds of projects assist our youth out at Siksika Nation and our contractors. So this is a picture of Elroy, one of our electricians, installing a conduit on the 1st building. And when he came in, we wanted to employ Nation members with this project. It's important for economic development that Nation members have an opportunity to be part of these kinds of large projects. But a lot of the contractors can be very intimidated by a project like this. And in fact, Elroy didn't really want to actually commit to it at the start because he was too worried about it. He didn't know if he could do it. And so instilling confidence in contractors out here and exposing youth to new types of building technologies is extremely important for us. We have a youth employment program that has about a dozen students in it looking towards getting their certificates for journeyman plumbing and electricians, carpentry. And sorry, that's just my coffee machine. And so I think it's been an inspiring project for the youth, but it's also been something our contractors have learned a lot about, and has given them confidence in their abilities. And it's something we've, Mauricio and myself and others on the team who are familiar with different types of technologies to give them the confidence to do this themselves. So this is a picture of one of them bedrooms. You'll notice that cutout on the left side in the wall there, and that's done purposefully because in Blackfoot culture, we have a lot of people in the community who we call bundle holders. They hold bundles, sacred bundles, and for the different societies that exist in the Blackfoot community, and those bundles are something that are traditionally stored above the headboard in the bedroom. So that's a little space for a sacred bundle. We do have bundle holders who are in need of emergency housing, and so we imagine that some of them will make use of that to store their bundles. It's a repeat photo, so you've seen that one. So it's just some learnings. It is, it's a new technology. It's a very exciting technology. There are limitations, of course, with the size. You can only print on up to, with this machine, which is the largest of the two machines that Nidus owns, prints on about a 60-foot by 40-foot area. And it's something, we're figuring out as we go. We're building the ship as we sail it. And there's been, modifications along the way as we've gone through this, which is interesting for me coming from the city of Calgary, where I was enforcing, on development permits and following a very regulatory environment, to somewhere where we don't have development permits and we don't have building permits in place, although they are going to be coming. We're installing those things, but it's allowed us the freedom to make adjustments on the fly without going through onerous approval processes. We do have engineers involved every step of the way on this project, advising us and approving drawings as needed. And then on the cost side, if we didn't have to deal with those winter costs, we would have been able to deliver these units for substantially lower price. And so it's very important in terms of delivering affordable housing in future, that this technology, I think, maybe not for single detached housing, but definitely for multifamily, spreading those costs across multiple units and even multiple stories. You could stack these machines and do, 2, 3, 4-story buildings. That's one way on how we're going to be able to deliver affordable housing in future. And so we expect that these costs to continue to go down over time. So it'll be interesting to see how all that unfolds. I also wanted to highlight another project, and I'm just about finished the presentation, and then we'll open up for questions. But we do have another innovation project we're working on in collaboration with Ecoplast Solutions and Polar Block. And so these was coming out of a need to deliver housing that reduces energy poverty. We have a lot of homes that are not energy efficient out on the nation, and people really struggling and not being able to pay their utility bills because of that problem. Now these are homes, you'll notice this photo has two different colors. The bottom portion in the yellow is the Polar Block component, insulated interlocking block system that's filled with concrete that provides a foundation, R value of about R31, I believe. And then the top portion, which is a panelized construction system using panels made out of recycled plastic bottles. These are energy efficient. I think it's about an R35 for the top portion, if I'm not mistaken. We have a huge problem with mold out on the nation. These homes will help with that. There's no, I'll show you a picture of the interior in a second. You'll see there's no 2x4 construction in these at all. The panels are structural, extremely energy efficient, and will be durable for a long time and help us reduce energy poverty on the nation. So here's just a picture of those interlocking blocks just about to go on the footings. And here's a little video of one of the panels just being lifted onto the roof onto one of these homes. And so this home was, after the foundation was finished, those panels, we assembled the home in about a day. And then it's conventional construction on the interior, say that you don't have 2x4 construction. So you do have to put veneers affixed to these plastic walls. I believe they're coated in a fiberglass treatment, and then these veneers are mounted on so we can affix drywall to the interior. Excuse me. And then we did receive funding from Alberta Eco Trust on this, and then from Saria as well we're doing an energy audit on these right now, and we'll be very interested to see the results. In our initial look at these, just anecdotally, on a very cold day, without any furnace running, the homes were very markedly much more warm than a traditional house. There were no drafts, there were no visible sort of um, leaks around the doors or windows. They're very airtight. So we're expecting a very good result from these studies, which we'll share with the community. And then just to finish it off, this is a picture of about half my team a few weeks ago out on the site. And so just want to recognize these guys for helping deal with some enormous challenges that we have here on the nation, and just say that this project has been quite inspiring for the team and the community. And we've learned a lot from it, and we're very excited about the lives of the future residents who are going to be living here. And so I'll leave it there, trying to leave some time for questions. So thanks for the opportunity to present. I'll turn it over to you for your questions now.
Excellent. Thank you very much, Ryan. So a few questions in the box for you that were put in beforehand. So one that kind of brings together a few is, I guess when you're looking at training, that's more of an overall question. When you're looking at training some of your new skilled trades, are they being exposed to the new technologies, the heat pumps and the other renewable energy systems, so that the nation could look at implementing those, I guess, in future builds, to kind of start to move away from the fossil fuel networks?
At the moment, there's nothing formal in place, although there should be. That's something we need to integrate. We'd be open to collaborating in that area if you or anyone in your networks know. Part of the problem is there's not a lot of people who have a connection to us. We're starting to reach out and pull in the help. So we're definitely interested in that. It's just that we're not set up for it right now.
Fair enough. Yeah, it's always tough to start up to add new skills. I guess there's a question about how long does the actual final curing of the concrete take, and I guess you left the tent up to make sure it stayed above zero. But is it like a few days? Is it a week? How long is, I guess, the final curing process before you can move that bubble?
Mauricio, do you remember that?
So the curing process is relatively fast. This concrete is designed in a way that that every layer will cure relatively quickly to resist the upcoming layer on top of it. So it will have some additives to speed up the process. Of course, so it's not necessarily the moving of the tent is not necessarily exclusively related to the walls themselves, but also to making sure that the slab doesn't suffer any frost damage. So essentially, once the whole envelope, the roof is once the whole envelope is ready to go and the roof is ready to be installed, then we move the tent. So it's basically, in this case, it was a few weeks, per building, and again, it's based on the completion of the entire envelope, rather than just the curing of the concrete. I also saw in the question that there was an additional, let's say, question about how the material is affected by the weather. So we took some in the design process. We took some that into consideration. So at the bottom of the first layer, we have some some water stops. So we have some one of those profiles that will expand when in contact with water, just to make sure that the water doesn't sip underneath the concrete. So, but other than that, it's essentially a relatively solid construction. It will react just like any other concrete wall.
Good, thank you. I guess a bit of a question. So with the insulation on the wall, you have the one wave and you have at least, looks like 2 or 3 inches of the spray foam on the outside. But I guess at the windows and any other openings where you do have the concrete continues from the inside to the outside, was there any concern or was there being modeling done on the thermal bridging, maybe at the openings?
So we minimized all thermal bridges. So at the windows, I mean, we do have a little bit of a, let's say a standard wall around on top and at the bottom of the windows. That was done just because we realized a little bit late, the architecture team had made a mistake and we had actually proposed windows that were too big. The students in my team, they wanted to kind of give the interior space, a lot of natural light, and they put essentially the largest window that was commercially available. And then we realized, no, that's just going to be a little bit too big because there might be some, there were some concerns about the possibility of, or like the need to replace these glass panels in the future if something happens. So we had to essentially reduce the sizes of the windows, which meant that we needed now to have about a foot of traditional wall on top and at the bottom of those windows. That meant let's say a traditional wall. And so that's insulated, but we do have the studs, right? So those will be the only thermal bridges. Other than that, all the design has been done so that we don't have any thermal gaps. We do have rigid insulation on the outside of the bond beam, so that's not necessarily seen because it's covered with the outer layer of concrete, the outer veneer, the 3D printed veneer. But we do have rigid insulation there, and we will install. It's not in this picture, but we also have rigid insulation at the bottom of that, the top of the window there. I'm blanking here. So the metal plate that bridges the walls and allow the window to be installed. So essentially all the connections, all the details have been developed to minimize all thermal bridges.
Okay. And so was there, I guess, a full energy model done, or I guess since it's kind of new concrete, it's hard to model it because it's
Yes,
so
no,
new?
we didn't do a full energy. I mean, again, this is the first building in the province, and there's just not a lot of past examples that we can draw information from. So this will be done after, as we look forward into the possibility of expanding this technology in the nation and maybe building other projects.
Yeah. So I guess the energy use will be modeled or monitored for a
The
number of
performance,
years. And
right.
yeah. Oh, excellent. There was a question about, I think you answered. So the blocks that the printer sits on, you moved those each time, so you didn't have to build a permanent foundation for them?
That's right. Yes, that was the idea. I mean, as Ryan explained, initially we wanted to have embedded, anchors on the concrete, let's say, platform around the buildings themselves, but we decided against that and just have these temporary buildings, let's say, foundations that we can just move from one place to the next.
Excellent. I guess question to Ryan, and you can dodge this one if you want. From that 2.6 million, was that the total funding, or because of winter conditions, do you need a bit more? I guess how much was that costing how much did the 2.6 million make up of the total budget?
So for the hard construction and materials and labor and everything, yeah, $2.6 million has been enough. We had some contingency, but we've got an open ask with Indigenous Services right now to contribute additional funding towards to recover heating and hoarding costs. And those are still coming in. We're still getting bills because it is only February. So I don't know the total impact of that at this point, but I'd say, we're probably looking at maybe 20% addition to the overall budget because of that heating and hoarding.
Yeah, that's very good, because that's 16 homes for 2.6 million is like 160,000 a home, which
Yeah.
is pretty affordable.
Yeah.
for as far as finishing, do you leave the concrete exposed for the look? Are you painting it? Is there another finish that needs to be applied? What's kind of the final finish?
So no, we actually we really like that finish. So I was in love with it. You know, we and the students, we all loved it. There were some conversations about maybe providing the outer layer with maybe with one of kind of grayish paint to kind of, you know, provide a more uniform color. But no, we you know, I think it's the quality of the space is partially based on the expression of this material. So we didn't want to kind of disguise that, or so it's I think a really uh beautiful look.
Yep, definitely.
Yeah,
And
inside, however, of course, you know, there might be something else. There were some conversations about maybe painting it, you know, in a more kind of clear color, or like on a more, you know,
brighter white
lighter.
colors. Yep.
Yeah. But of course, you know, we have all the conventional walls with regular drywall. It's also, I think, worth mentioning that because all of these units are, I mean, every building has 4 independent units. We went the extra mile to provide all the spaces with double the fire rate, you know, required by code. So essentially, you know, we have 2 hours fire rate, so it's all double drywall. So you know, with fire caulking and everything else. So we, you know, we paid special attention to that as well.
Excellent. Yeah, very durable. For the roof attic, is it, I guess, just a conventional vented attic? And did you kind of use, I can't quite tell if you did use the high heel energy trusses just to make sure you're continuing the R value on the attic side?
The ceiling is insulated at the moment. So, but the attic is not. So I don't know if that's what you're asking. So all the interior spaces are insulated. We have the insulation on top of the ceiling.
Okay, good.
Yeah. And then we did is that this what we designed is to have is we had, you know, the loose insulation on top, and then we had designed a rigid insulation at the bottom, just to make sure that we also minimize any potential thermal bridges where the trusses go. I think at the end there were some conversations about, you know, because again we're working. It was not 100% possible to meet the design specifications. You know, working with a relatively, you know, tight time frame and with local labor and everything. So I think there was a decision at the end to change the loose insulation also with spray foam insulation. We do have R40 on the ceiling, so it's actually really well insulated. But I think we moved against having the rigid insulation underneath hanging from the trusses.
Okay. Maybe coming back a bit to kind of the embodied carbon. So the spray foam is the new spray foam formulation, so it is lower embodied carbon, similar to mineral wool and EPS. But is there looking at maybe in the future using cellulose to get some kind of carbon sequestration in the project, or would you just need more thicker walls? And would that I guess, has that been looked at using lower embodied carbon insulation?
We are, I think the best way I can explain this is that we are very you know, excited about the possibilities, and we look forward to expanding what this technology has to offer. In this case, we didn't, and I must admit it was a little bit of a, you know, from 0 to 100 in you know, it very quickly. So we had to actually get the project going to try to finish as much as possible quickly before the winter, so that we didn't spend too much time looking into new materials. But of course, there are ongoing research projects, and I think this is what I think one of the most amazing things about this project is the willingness of the nation to work together with the university to look into all of these, you know, let's say research questions collaboratively. So the thickness of the wall, the embodied carbon inside the concrete itself.
Yeah.
Right. So, and on top of that, of course, all the insulating materials that can be used. and as Ryan mentioned, also the heating system. So there were some questions about passive, solar, maybe using some either some PV panels or just some maybe not for electricity but for heating. All of these questions are still open-ended, and we very much look forward to looking into the possibilities.
Yep, excellent. I guess quickly back to HVAC. Is there an HRV or an ERV installed for permanent ventilation, or is it just the furnace fan?
No, we have a heat recovery vent.
Ventilator, good.
Yeah.
And since on all the perimeter walls, since the utilities, the electrical plugs and stuff are all in it, so it's kind of like a commercial wall where they've run conduit to boxes and the exterior walls, and then you pull wire in later if you ever need to replace anything.
That's right. Yeah, so we were also approached, and Ryan can probably speak, better about this, by a company who was really interested in demonstrating their new, PV panels, and they were willing to actually, provide the project with them. But of course, this is a decision that we really look for, to new projects, because they can be all of these buildings can be arranged, thinking about the solar gains a little bit better. So in this case, the decision to organize these buildings in the way they are and having this internal street was also to activate the local center of the neighborhood, if you will, and provide that open area where kids can play, where, there can be community gatherings. But that meant that the buildings themselves are not necessarily all arranged in a more efficient way for solar gain. So I think there was only one building that could really benefit from having solar panels. So we decided, maybe not to take them on this offer, but I think, again, looking forward to future possibilities, this is something that could be implemented.
Yep. And is it a standing seam concealed fastener metal roof, or because that's the easiest thing to put solar panels on? So starting with a nice simple gable roof, sticking solar panels on in the future should be fairly simple.
That's right.
Yeah. All right. Yeah, so Lafarge and the concrete kind of world in general is getting pretty good at, or at least actively trying to drive down the embodied carbon of concrete by just using fly ash and other supplementary cementitious materials. So that's good and will continue. I'm just looking through other questions. So I assume Nidus 3D owns the Kobo printer and just moves it around to their various locations.
That's right. Yeah, I think they own two machines. This is they have the large one out here. They have a smaller one that does single detached houses out in Ontario. And so they actually are set up to actually sell the machines as well as sales and training. And so that's something the nation is considering doing maybe down the road. So they would not only act as a home builder, which they're doing for us right now, but they also will sell and train teams on how to operate the machine.
Excellent. A little bit back, I guess more of the way that the nation works. Does the nation actually have a full natural gas grid, or are you all just on tanks, or are you on propane? I guess it's kind of leading towards maybe using more all electric in the future, depending on what utilities are.
Yeah, that's a good question, and that's largely through the gas network. But just looking back, we had a state of emergency in about mid-January where ATCO regulator went down at about 3 a.m. and shut down gas to about 934 homes out at Siksika, and so it was out for about 7 or 8 hours, and so we looked at that, and the older furnaces were not self-reigniting, so we had a lot of service calls to go and assist people with reigniting furnaces, and so now we're seeing definitely a vulnerability on that network, and possibly having supplementary systems would make sense. We delivered a lot of electric emergency heaters during that period of time. going all in on either, you know, one or the other. It's tough to say which is the better thing to do. You know, you look at how the car industry is going, and hybrids make a lot of sense because you've got two different systems in a vehicle. You know, we get an electrical outage, then we really don't have anything, and we don't have, you know, we'd be looking at basically bringing in temporary propane heaters at that point, because we probably, for us, because a lot of the homes are quite remote, looking at having a heating system, maybe a heat pump system, but also a backup system is going to be really important should you have, you know, these kinds of large network outages that happen. So I don't know what the right answer is, but I do know, you know, we have seen vulnerabilities in the existing infrastructure that have caused a lot of problems for us on the energy side.
Yep. I guess we need to get you a grant for a ground source geothermal
Yeah.
system.
Yeah, exactly.
Yep.
We
and
I think it's also worth mentioning that, you know, these units, they all have individual electrical meters, and we did some calculation. I mean, the initial goal was to have no burning processes inside inside the building. So it was to be a fully electric project. We had the heat pumps, we had, of course, electrical stoves, electrical on-demand water heaters, and so on. They're relatively small units, so we didn't have a lot of space for, you know, for water tanks and things like that. But that was the initial goal. But then we later on, and, you know, also, you know, after having to deal with these power outages, we also did some calculations, and we realized, well, the electrical bills for these units, even though they're really well insulated, you know, they can be relatively high, you know, and we realized, okay, so considering that these units are tailored to house transitional, I mean, they're transitional housing. You know, we needed to take into consideration the resources of the potential inhabitants. So the finances involved in having to pay for these really high electrical bills. So we decided we had to make the decision to say, well, you know, maybe it makes more sense for this project to go a little bit more traditional and go with gas. And that's how we changed from heat pumps later into in-floor heating and having gas in the residences.
yeah, it's well, we are coming up to one, so I'm sure we could geek out on the specifics of the 3D printed house or the overlapping crises that are the much larger picture. But thank you, Ryan. Thank you, Mauricio, for your willingness to try new things, and I guess the ability to try new things. And yeah, we will see you all at the next Passive House Coffee Talk.
Sounds good.
So,
Thanks.
thank you, Frank, and feel free to distribute my email address in case anybody has any questions.
Yep, yeah, it looks like Ryan had a something for his MBI, so we might send out a little email to all of the attendees with some follow-up data.
Okay, sounds
Awesome.
good.
Thank you very much. Yeah, great project.
Thank you.